Well, welcome back, everybody. We are on our last lesson of 7.2, still on volume. This is called the washer method. And what I'd like for you to do is take a look at the graph I have. I have the graph of y equals x cubed, graphed from x equals 0 to x equals 2. I'd like for you to think about what would the radius for each cross-section be if we rotated this region about the x-axis. Okay, so if I wanted to rotate this guy about this yellow region here about the x-axis, what would each radius be? Well, I could start at my axis of revolution and go up to my function, and I see that this would be a representative radius r, right? So r would be x squared. So, I'm sorry, x cubed. So if I wanted to find the volume of the region, that yellow region rotated about the x-axis, it would be pi times the integral from x equals 0 to x equals 2 of r squared dx, right? And r squared is x cubed. So x cubed squared would be x to the 6th. Okay. Now, what if instead I wanted to revolve that yellow region, this yellow region, about the y-axis? Okay, let's take a look at that. So now I want to revolve about the y-axis. I always have to go from my axis of revolution perpendicular to my region. Now, if I selected this as my radius, I'm not rotating that yellow region, am I? I'm rotating all this empty space. And if I select this for my radius, I have too much, right? So if I try to rotate about the y-axis using the disk method, I run into a bit of a problem. Okay, and we're going to look at remedying that problem today. So essentially what happens when you try to rotate a region about an axis, but there's some empty space between the region and your axis of revolution? Okay, well, what's going to happen when I rotate? Let's come back to this. If I want to rotate this, can you picture what a slice would look like? And kind of give you a hint there with the upcoming slide. A slice would actually look like a washer. Okay, so it would be a circle with this big radius r, with a smaller circle with this radius little r cut out of it. All right, so each cross section is going to have is going to look like a washer. Okay, with very infinitesimally thin depth. All right, so let's take a look at the area of a washer. So let's say here's my washer. Let's say here's the center. Let's call this, instead of r sub o, let's call this capital R for the big radius, and let's call this lowercase r for little radius. Okay, so the area of a washer, would you agree it's going to be the area of the big circle minus the empty space, minus the area of the small circle? Well, the area of the big circle is pi capital R squared, right? And the area of the little circle is pi little r squared. So to make it look kind of nicer, we could factor out the pi and get pi times the quantity capital R squared minus little r squared. Okay, and that would be the area of this washer. So if I want to calculate the volume of a solid formed by rotating a region bounded by two graphs, and so we'll say it has an outer radius of capital R and an inner radius of little r, then I'm going to follow a very similar formula. I want to sum up a whole bunch of washers. So from A to B, I'm going to plot that factor of pi out in the front. And then my formula for area of washer is big R squared minus little r squared. Dx or dy, depending on your axis of revolution. Okay, so all it's going to really come down to is figuring out what your two r's are. Okay, so let's try a few examples. All right, would you take a moment, pause the video, and copy this graph in your notes? Doesn't have to be perfect, but you have a graph of f of x and the graph of g of x, and they intersect at, looks like 0, 0, and 3, 3. Pause the screen, draw it, and then we'll try each of these. All right, so we want to set up the integral that would revolve the given region about the following lines. Okay, all right, so for part A, I would like to revolve this green region, the region made by the graphs of f and g, about the line y equals -1. So I'd like for you to take your pencils and draw in the line y equals -1. Okay, now decide if this is going to be disk method or washer method. This is going to be washer method. How do I know? Because there's some empty space between the region I'm revolving and my axis of revolution, right? There's a little empty space here and here. Okay, so the formula I'm going to use is pi times the integral. Now, do we want to use dx or dy? We want to use dx because this is a horizontal axis of revolution, so that means my limits of integration must be x values. So what should my limits of integration be? Well, they should be 0 and 3 because my x's go from x equals 0 to x equals 3. All right, and my formula is capital R squared minus little r squared, right? And we decided this would be dx. Okay. So how do we determine capital R and little r? Well, when you have a picture, it is pretty straightforward. I want you to start at your axis of revolution. You can start anywhere that you have some empty space. Okay, start at your axis of revolution, go perpendicular up to your farther function. That right there is going to be capital R. Okay, then start at your axis of revolution, go perpendicular to your closer function. That right there is your little r, right? I want to take capital R, rotate that, then I want to subtract out this empty space. So that's my little radius. Okay, and now we're ready to write our formula. So I have pi times the integral from x equals 0 to x equals 3. Capital R, do top minus bottom. So that's going to be f of x minus -1, which would be f of x plus 1, right? And I want to square that. Then I want to subtract out little r. So again, do top minus bottom. So little r is going to be g of x minus -1. So that will be g of x plus 1 squared dx. Okay, be sure that you're squaring both big R and little r. Don't try to square the whole thing in parentheses, okay? Don't be stingy with your squares. Okay, let us try part B. So go ahead and erase, maybe. Go ahead and erase what you added to your graph for this example. And let's do part B. Okay, part B says take this region and this time rotate it about the line y equals 4. Okay, so come up to y equals 4. Draw that horizontal line for me going through the y-axis at 4. Okay, and I would like to rotate about this line. So disk method or washer method? It's going to be a washer method also, right? Why? Because there's some empty space between the axis of revolution and the region you want to rotate. So we're going to start with our washer formula. Dx or dy? It's going to be dx because why? Because you have a horizontal axis of revolution. So that means all these need to be in terms of x. So I still am going from x equals 0 to x equals 3 of big R squared minus little r squared dx. Okay, and now we just need to find big R and little r, and then we'll be done. Looks like I didn't get that one erased, huh? All right, so to find big R and little r, always start at your axis of revolution and go perpendicular to your farther function. Okay, that's going to be capital R. And then little r, start at your axis of revolution, go to your closer function. This is the empty space, right? That'll be little r. Now just apply top minus bottom and we're there. So pi times the integral from 0 to 3. Capital R is going to be, now be sure you do top minus bottom and not bottom minus top, although computationally it'll work out either way in this case. But so big R is going to be 4 minus g of x, right? Square that. Then minus little r, again do top minus bottom, that's going to be 4 minus f of x. And square that, dx. And that's it. Okay, would you pause the screen and try part C for me? Please erase all this stuff in your notes. Try part C, and then I'll show you the answer and we'll see if we got the same thing. Okay, so pause, please. All right, this is what I got. Should be real similar to what we got in part A. Just where we had 1s, we should now have 3s. Okay, so you can go back and look at how we did part A if you got part C incorrect. Okay, let's try a couple more. It says set up the integral that would revolve the given region, the region in the first quadrant bounded by y equals negative x squared plus 1, about the following lines. All right, part A says rotate about the x-axis. So this is the region I'm looking at here, yeah? And I would like to rotate about the x-axis. So for part A, would that be disk or washer method? That'd actually be disk, wouldn't it? Because there's no empty space between the region you're trying to revolve and your axis of revolution. So all I need to do is find capital R. Okay, so remember the formula for disk is pi times the integral. Now will this be dx or dy? This will be dx because horizontal axis of revolution. So pick x values here. So we're going from 0 to 1. And it will be capital R squared dx. Okay, so R, do top minus bottom. Well, this was the graph of y equals negative x squared plus 1, right? So r is going to be that negative x squared plus 1 minus 0. I don't need to write the minus 0, but you certainly can if you'd like. And then I want to square that. And that's it for part A, okay? Disk method. All right, how about part B? This time I would like to rotate about the line y equals 2, right? So go ahead and draw the line y equals 2. It's going to be somewhere up here. And I'd like to rotate about this line. All right, washer or disk this time. This is going to be washer. Why? Because there's some empty space between your axis of revolution and the region you're rotating. All right, so I know that I want to use washer. So that's going to be pi, the integral from. Are we going to use x's or y's? We're going to use x's, still a horizontal axis of revolution, so that means I'm still going to have 0 and 1. So that'll be capital R squared minus little r squared dx, since we're using the washer method. All right, so now I just need to find capital R and little r. So start at your axis of revolution. Woo, go down all the way to your farther function. That's going to be capital R. And to find little r, that's going to be your empty space. So start at your axis of revolution, go perpendicular to your closer function. Okay, so pi times the integral from x equals 0 to x equals 1. Capital R, top minus bottom. So start here, finish here. So that's going to be what, 2 minus 0? So just 2. So 2 squared, or 4, either way. And then little r, top minus bottom, that will be 2 minus this function. So 2, be sure that you distribute that negative or put parentheses around your function. That's the most common mistake I see. dx, we decided. Okay, so that is the setup for the volume for part B. Okay, let's erase once more and let's try part C. So for part C, I would like to rotate about the line x equals -1, right? So x equals -1. Make this just a teeny bit smaller so we have some more room here. Oh, maybe not. Okay. So go ahead and draw the line x equals -1. It'll be over here, right? Probably a little farther, but we're out of space. So, okay, so I want to revolve about this region. I'm going to take this guy, revolve about this axis. So, disk or washer. This guy's going to be washer because there's some empty space, right? So for part C, I'm going to use washer method. Okay, dx or dy? Right, this time we want dy because I have a vertical axis of revolution. That means that my limits of integration here need to be y values, okay? However, it's still going to be 0 to 1, right? Because those are my y values also. So from y equals 0 to y equals 1 of big R squared minus little r squared dy. Okay, all right, so now I just need to find big R and little r. So start at your axis of revolution, go perpendicular to your farther function. That is going to be capital R. Start at your axis of revolution, go to your closer function. That'll be little r. Now this time, instead of doing top minus bottom, we need to do what? We need to do right minus left. So pi times the integral from 0 to 1. So down here, pi times the integral from 0 to 1. So capital R, if I do right minus left, is going to be this function minus this. Okay, what would be wrong about using negative x squared plus 1? Because we decided everything needs to be in terms of y, right? You can't mix in your x's and y's inside your integrals. Okay, so how could I solve this for x? Subtract 1 first, right? Multiply both sides by a negative. So I would get negative y plus 1, or 1 minus y. Then square root, right? And technically I would need plus or minus, but this guy's going to be the positive root, so you're fine there with just the positive root. Okay, so if I do right minus left now, the function minus negative 1, right? Because these are x values now in terms of y. So we have the square root of 1 minus y plus 1 squared minus, for little r, right minus left, I'd have 0, right, minus negative 1, or 0 plus 1, or just 1 squared dy. Okay. All right. I have one more example if you'd like to see it. If you are good to go, then you can start your homework. Otherwise, I will do this last example with you. It says, find the volume of the solid formed by revolving the region bounded by the graphs of y equals the square root of x and y equals x squared about the x-axis. Okay, so let me get a good picture going for you. So y equals the square root of x is increasing and concave down. Y equals x squared in the first quadrant, at least. I guess I can do a full picture. I'll try again. I'm just going to draw it in the first quadrant. Is increasing and concave up. Okay. All right, and I would like to rotate about the x-axis. Okay, so would you choose washer or disk method here? Should be washer, right? Again, because there's some empty space between this region that I'm rotating and the x-axis. All right, so we are going to have, we're going to use dx or dy in this case. Should be dx because we have a horizontal axis of revolution. Now, how could I find these points? Well, you may, maybe you just know the graphs. We could set the functions equal to each other and solve there, which is totally fine. These might be simpler to solve in your heads. This is the point 0, 0, right? And this would be the point 1, 1. Okay, both of those points are on these two graphs. So I want pi times the integral from 0 to 1, and we said we want washer method, and we want to use x's. Okay, all right, so for capital R, go from your axis of revolution perpendicular to your farther function. Little r is going to be the empty space, but same idea, axis of revolution, perpendicular go to your closer function. Okay, so I have the integral from 0 to 1. Capital R, we need to do top minus bottom. So that was the function square root of x, right? Bottom is 0, so you can write it in or not, doesn't matter. Square, again, don't be stingy with those squares. And then little r, top minus bottom. Top will be x squared, bottom will be 0 dx. Okay, so if you wanted to, this would really not end up being a very complicated integral to do by hand. This would just be the square root of x, and the square root of x squared would be x. This would just be x squared, and x squared squared would be x to the 4th. Not that you have to simplify it to this point if it's set up only, then I actually prefer that you leave it at this point so that you don't mess anything up in your simplification and lose points on your FRQ. All right, and that's it, guys. So good luck with washer method homework, and I will see you all next time.